Hello, this is Dr. Kishore. Today we will be looking into the difference between thixotropy, antithixotropy, and rheopexy. In rheology, thixotropy is an isothermal and slow recovery of a material which is removed from the applied shear stress. So, if we see in rheology, best explained using rheograms. So x-axis is shear stress and y-axis is rate of shear. For a pseudoplastic material or shear thinning material, when we apply shear stress, the rate of shear slowly increases. So this increase in rate of shear is due to the decrease in viscosity. So increase in rate of shear is due to decrease in viscosity. When we remove the shear stress, the shear thinning systems comes back to its initial position very slowly. The slow recovery is due to increase in viscosity. So when it is recovering, it will recover very slowly. So if we see in shear thinning systems, the upward curve and the downward curve. So upward curve during application of shear stress, downward curve during removal of shear stress. So the downward curve is always shifted to left side of the up curve. This is due to decrease in recovery speed. This decrease in recovery is due to increase in viscosity. So when you are applying force, viscosity decreases. When you remove force, viscosity increases. So due to increase in viscosity, the recovery of shear thinning systems is very slow. This phenomenon of slow recovery is thixotropy. So if you take a gel with high viscosity and apply shear stress, its viscosity decreases and forms like a solution or less viscous. When we remove the shear stress, the sol will go back to its gel state. So this is a slow process because when sol is becoming gel, the viscosity is slowly increasing. When viscosity is increasing, flow is less. So obviously it is coming very slowly. So this slow recovery is what we call as thixotropy. In case of antithixotropy, if we increase the shear stress, rate of shear slowly increases, just like shear thinning systems or pseudoplastic systems. And when we remove the shear stress, there is shifting of down curve towards the left side of the up curve for a thixotropic system or shear thinning system. In case of antithixotropy, this down curve shifts towards the right side of the up curve. So the down curve shifts towards the right side of the up curve and recovery is slow. And when you apply shear stress for certain recovery point, so it reaches to certain recovery point. When you again apply shear stress and remove shear stress, again it comes back to right side, and again you apply, again it come back. So what is the difference we observe is, in case of thixotropy, the shifting is towards left side and recovery is slow. In case of antithixotropy, the shifting is towards right side and recovery is very slow. And as we observe, if we continuously apply the shearing stress on antithixotropic systems, there is always certain amount of permanent loss in its shape or integrity. And as you keep on applying this force, at certain point, the material will completely become from gel state to sol state. So this complete conversion is possible with continuous application. So in this is what we call as antithixotropy. So if we see, the saturation point is the point where the saturation state is nothing but the state in which it is existing before the removal of stress. So when I apply force on a thixotropic material from gel state, it goes to solid state. So here this is saturation point. It is the same in case of antithixotropic materials also. So from gel state it will go to solid state. So in both thixotropy and antithixotropy, the saturation state is solid state. And coming to rheopexy, rheopexy is conversion of, is same as that of the thixotropic behavior, but in thixotropy gel becomes a sol, whereas in rheopexy a solid becomes gel. So a stiff solid material, upon application of shear stress, it becomes gel. And when you remove stress, again from gel state it will go to solid state. So the saturation point for rheopectic materials is gel. So gel is the saturation point. And generally we won't observe rheopectic materials in pharmacy, but we can observe in mechanics or any other type of subjects. So overall, thixotropy is a slow recovery where the down curve shifts towards the left side. Antithixotropy is also a shear thinning behavior where the down curve shifts towards right side. So if we take examples for thixotropy, we can say acacia or all gum solutions. If you want to know for antithixotropy example, you can take magnesia magma, which is a suspension, or milk of magnesia. So these are the examples for antithixotropic substances. Thank you.